work with you for Phys Lab. Now I got a couple questions about how Phys Lab is going to work. So for anybody who's a little confused about that, I want to walk us through the bright space real quick. Hold on, I'm setting
work with you for Phys Lab.
Setting up a recording, so I got a little echo. Okay, there we go. Okay, so what you should find under your normal lecture course, right? Go to content. You have all of Dr. Richards' normal modules down here. So each of your exams for lecture, you have your mastering A&P links. Then under lab, you have a beginning section for orienting you to lab generally, and then you have tabs for anatomy lab and for physiology lab. So today we're in the physiology lab section. You can see this is broken out by labs 1 through 5. So those of you who received my calendar invite, I've taken into account the sort of weirdness of this spring schedule so that you know which lab we're doing every day. If you look into the details of the Zoom link in the calendar invite, it says we're working on lab 1 or lab 2. But if not, you can still find that lab Zoom link at the beginning of this physiology lab section. Always going to be the same link right there. I'm going to talk for a little bit at the beginning of each lab, but most of the lab is going to be working through lab packets, learning how to take various types of physiologic measurements, learning how to work with the kinds of numbers we are going to find from our recordings in lab. But you can find YouTube links for whatever my portion of the speaking part of lab is here. Okay, so what we're going to do each day is we're going to go through a worksheet. So you'll have a link here to today's worksheet. Should have opened that in a new tab. So here's what we'll be doing in class today. Working through a worksheet. And I'll make sure that that is doable virtually. Looked a little different than I expected. You'll then have a short worksheet completion quiz at the end of class. This is not like a quiz. This is basically just you're filling in some of your worksheet answers, some of the concepts that you've just worked through to make sure you did lab and you understood lab. We'll occasionally have short videos that are just like explanations of things we thought might be tricky in lab. So that's what these concentration problems are. And then the following week, so starting next week, at the beginning of lab, we'll begin with a quiz on the previous lab. So this isn't available to you yet, but during our next lab, which I believe is not until, that'd be right, not until several weeks away, we'll begin with a short quiz on the lab we do today, followed by another lab worksheet, another short lab completion quiz, and so on. Okay, I can see I got someone in the chat. Oh, saying hello. Okay, great. Okay, so, looks like some of the due dates on some of the labs haven't been updated from the previous time we ran this course. So I'll go through those today and make sure that they're all correct and all coming in correct on your calendar. Sorry about that, everyone. Okay. But before I do that, let's get started with the content so you have all the information you need in order to do this lab today. Okay. So today we're talking about a pretty basic concept. We're just talking about measurements and how we relate measurements to each other. It's going to be really important in both anatomy and physiology in terms of research. Where we're really doing research and working with numbers for this course is in physiology, which is why we're talking about this in Phys Lab. So you guys have probably talked about different types of measurements before. You've probably done dimensional analysis before, which is really the focus of this lab. But short primer, right? We have very specific ways different units of measurements are related to each other. So we use something called dimensional analysis and conversion tables to convert from one unit to another type of unit. We'll also see that we have specific relationships between different types of measurements, like different types of measurements here. I mean, not the units specifically, but whether we're talking about length whether we're talking about mass, which is kind of like weight, or whether we're talking about volume, right? These are going to be a little trickier to convert between because we're going to need to know additional facts other than just relationships between the units. But that's what we're going to be focusing on kind of thinking about today. Okay. So for today, if you don't have these memorized, this is fine. But these are just some tables comparing different measurements that we'll see. All right, so we can see that in the metric system, we start with a base unit, and then we use multiples and specific prefixes to go up and down from that base unit. All right, so if we start with a unit of meters, we can see that a kilometer, kilometer, would be 1,000 meters. But if we wanted to know what a centimeter is, right, we'd have to go down. So it would be smaller, the opposite direction. We can also convert between the metric system, which is our standard scientific set of units, to the imperial system, which is a system we often use in daily life, right? So we often measure things in miles rather than in kilometers because we're in the US, right? So there's a specific relationship there as well. So 1 kilometer is equivalent to about 0.62 miles, so a little more than half a mile. So we want to be able to convert between those two systems as well. For these, I'd like you to have sort of a ballpark idea in your head. You don't need to memorize these exact values, but like I would like you to know, for example, that a kilometer is smaller than a mile, things like that. You should have kind of a little bit of a gut feel for. We do similar things when we're talking about mass and when we're talking about volume. We have similar types of relationships. Oh, we can, of course, also do the reverse, right? 1 kilometer is a little more than half a mile, which means that 1 mile is a bit less than 2 kilometers, right? So we can convert in either direction. We just have to pull up the right conversion factor. Okay. The reason we care about this in physiology and in fields involving medicine is that we're often going to have to give people very precise amounts of medications and factor in how that relates to, for example, their body mass or their blood volume or the concentration of something in an IV bag. So we need to be able and comfortable moving between different types of units, because whenever we're measuring something, we pick the unit that makes the most sense for a measurement, right? You're not going to measure a human being in grams, right? Your number would get too big. It's not a realistic unit for a human being. But when we measure pills, they're very small. We may measure them in milligrams. So we're going to need to be able to relate that to, for example, the mass of a person. So that's why we need to be able to kind of go from one type of unit to another type of unit. So we might have a problem like this, and we'll go through various word problems in the packets. That's why we're doing the packets. They might have a patient who needs 650 milligrams of Tylenol every 6 hours, but maybe your pill doesn't come in 650 milligrams, comes in 325 milligrams. You'd need to figure out how many pills to give that person. Now, this one we can probably all do in our head, right? Seeing these two numbers, how many pills do we need to give someone 650 milligrams of Tylenol? But we're going to set it up like this was a hard problem and we didn't kind of immediately see the answer. So if we're setting this up as a dimensional analysis problem, we want to figure out, right, what's our question? When we're solving this, we want to kind of know what units we're going to want to come out to as we're trying to figure out how to set up our problem. So in this case, we know we're looking for a number of pills, right? There are lots of ways we could manipulate these different numbers, but we know our question is saying, how many pills does this person need? Okay. So that's going to go on the right-hand side of our problem. And then we're going to start filling in other things that we know, right? So the other thing we know is that this person needs to be given 650 milligrams. So we need some number of pills that is equivalent to 650 milligrams. And now we're just trying to figure out how we do conversions to end up with the same quantity, except with pills as our units, right? Okay. We do this using something called the identity property, which is that you can multiply things that are equivalent to one. Sorry, I will repeat that. 1 times anything is the same number. So you can multiply anything by 1 and not change its actual value. And we take advantage of this in dimensional analysis by being really tricky with how we write our ones, right? Like in this case, what we're actually doing is just multiplying by 1. But what we see is that 1 pill, so that's 1 pill, that's the same amount as 325 milligrams, right? There are 325 milligrams in each pill. So we put that on the bottom. So really what we're saying here is 1 pill over 1 pill, but we've written this bottom part using a different number of units. I know I have just made a very easy problem sound quite hard. That's why we're starting with an easy one. But hopefully you guys have done this stuff in chemistry before or in different types of math classes. So we're multiplying by 1, except it's secretly in different types of units here. But if we changed it to the same units, this would just be multiplying by 1. But because one of those units on one side of that dividing line is the same as this unit over here on the top that we started with, we can then cancel them out. And that's why we got all tricky with this, is so that we can cancel out the units we start with and end up with the units we want. So here we cancel out our milligrams, right? The only units we're left with is pills. So now we can do what we wanted to do in the first place, divide 650 by 325. And we can confirm using this math that our units on that is going to be pills. So this is basically what we're doing when we do math in our head. This is also what we're doing when we're doing more complicated math. I will leave it up to your judgment as you go through your problems in your packet, whether you want to do this kind of just how intuitively the math feels to you, or whether you want to practice writing it out this way. I'm not going to be grading for, did you set up this math problem exactly the way I think it should be set up? But if you're really struggling for how do I come up with an answer, try this. Okay, so we got 2 pills. So now we want to think about relationships in the metric system. So that was just converting units, right? Now we want to think a little bit about our ideas of length and volume and mass. So we're going to start with an imaginary cube. This imaginary cube is going to be 10 centimeters on one side, 10 centimeters on the other side, and oh look, it's also 10 centimeters tall. So here's our imaginary cube, and we're going to imagine this cube is made of water because basically everything in biology is mostly water. Okay. So it's a fact that a cube that is 10 centimeters on every side encloses a liter of volume, but we can also express that liter of volume in centimeters, right? These sides are measured in centimeters. So we could have a volume measurement that incorporates that centimeter unit, all right? So if we multiply 10 by 10 by 10, we'd see that the volume of this cube is 1,000 centimeters cubed, right? 1,000 cubic centimeters is equal to a liter. And this is a relationship that's just going to be true here. So that's one we want to remember. In terms of what we want to know for physiology, it's helpful to think a little smaller than this. Our units are going to be smaller because we're measuring small things usually in physiology. So helpful to remember that 1 cubic centimeter is equivalent to 1 milliliter. Now, when we want to relate this to units of mass, that's why I told you this fake cube is made of water, because this is dependent upon the density of a material. But for the purposes of biology, water has a density of approximately 1. So we can say that this 1 liter volume weighs a kilogram which weighs 1,000 grams, right? Those are all equivalent measurements. That's all measuring this volume of the cube. But now we also know how much this cube weighs. Okay. This means that 1 milliliter also equals a gram. So before, right, we saw that 1 cubic centimeter is equivalent to a 1 milliliter. Now we know that 1 milliliter is also equivalent to a gram. So those are helpful things to remember, right? 1 cubic centimeter, 1 milliliter, and 1 gram are all going to be helpful ways to convert between length, volume, and mass when we're in physiology. So here we have a slightly more complicated problem that we could set up here. So here we have another pretend patient. This one needs 2,000 micrograms of something every 8 hours, but our medication comes in 4 milliliter vials. So now we can see that we have a measurement of volume and we have a measurement of mass. So we know that we're going to have to use that relationship between volume and mass in order to come to an answer. For simplicity's sake, we're imagining that the medication is liquid, has the same density as water. We're not really going to mess with density in this class at all. Okay, so we're going to start out. We know that we want a number of vials, and we also know that we want that number of vials to be equivalent to 2,000 micrograms. Okay, that's what we're trying to get to. So we're just trying to figure out how to get these units on either side to be the same, and then we'll do the math, multiply across, and then do the division on the bottom. Okay. So one thing we can do is we can convert micrograms to grams using that table, right, with our base units and going up and down to get smaller and bigger. So here we have that conversion. So that'll put us into grams. Next, we're going to use that association between grams and milliliters, right, to get us into milliliters. So now we're in a unit of volume. And cross those off. So we're in milliliters, but we actually want to get to number of vials, right? Because that's really what our fundamental question here is. But then we can use this final piece of information we had, which is that 1 vial is equivalent to 4 milliliters. So then we would even cross off our milliliters and we'd get our number of vials. So we'd multiply the top and then we'd multiply the bottom and then we'd take those two numbers and divide them. We get 0.0005 vials. Okay. So that's the kind of way we're going to be doing problems throughout this lab. Final thing we want to pay attention to is something called concentration. So concentration is going to be described in different ways depending on the context. There are 2 of them that are particularly common. So sometimes we'll see the mass of a substance per unit of volume. Sometimes we'll see the moles of a substance per unit of volume. The moles of a substance per volume is technically the standard way of doing it. The International System of Units, SI units, is moles per volume. But when we're trying to actually measure things out, for example, in a pharmacy, mass is more practical. So that's why we'll see this mass per volume quite frequently when we're thinking about physiology, when we're thinking about medicine. Cool. So I just have this chart up again for you because if we were in person, I would just leave this on the board. So I will make sure I put these slides up so they're accessible for you on Brightspace in case you want to pull these up on your own, or go ahead and Google them as we work through the worksheet. And I'm going to stop sharing now, and we're just going to break out and do some practice problems now.